In this set of slides, we're going to be looking at data detection. We're going to use the change in Omani livelihoods over time to illustrate this idea, which is given in a lot more detail in topic 1, but here we also can just give a brief reminder, which is that this case study examines survey data taken at 2 time points and illustrates the changing nature of farming ecosystems. The aim of the case study is to document both what happened in the past and consider a change and those perspectives in the future. Where this data has been analysed, there's been a paper written on it, which again you're linked to in topic 1. And this paper states in it that the interview data was entered in Excel database, coded and inspected for completeness of records, and so forth. Now, this completeness of records is kind of what we touch on here, this data detection. And again, plausibility of answers. These are all cleaning techniques that would have been done, and as they said, in Excel. And one way that they could have done this is with pivot tables, as we saw in topic 2, and another way is with filters, which we're going to introduce here. And almost certainly with a mixture of both. So detecting and recoding variables, there are powerful tools in spreadsheet software that can be used to clean your data. We've looked before at pivot tables back in topic 2, but again here, detecting with pivot tables can be very useful to detect incorrect values. So in this case, we have when we looked in topic 2 with pivot tables, we did a pivot table of our year as our column, year as our 2 columns, and on our rows we had the different households, and we expected there to be 1 or 0 rows for each column and household. That is every household. Sorry, for each year and each household. Sorry, we expect there to be 1 observation. And that means 1 row of data for each year and each household ID. And that's because each household was surveyed once in 2007 and once in 2018. Some households were obviously also not surveyed in this time, such as MA1 was not surveyed in 2018, presumably because they moved away. There could have been another reason why, and in these situations, you can dig into it, you could speak to the experts, you can find out what had happened there. It might well say it in the paper as well, that they might have found that out. But here, the values are consistently 0 or 1 when we're looking at our values, except for our totals, which sum up everything. If there was a value of 2 or more, this would indicate that the household codes in a village were not unique. This would be slightly problematic because we could then have some kind of mix of data where we don't want it, some data contamination. It could be that we're then unclear. Was it this household that gave that answer or that household? And that matters because it could be that one household had a huge, had a larger household size, and they had these different demographics about them than another household, and they said completely different responses. And then we kind of want to know, when we're doing our analysis, well, which household said those responses. If we have the same ID for multiple households, that's going to create a lot of confusion. And so we would want to sort those corrections at this stage now before furthering in our analysis. We can also detect with filters, and this is something that we look at in some detail here, and there's some really great guides at the bottom of this section. Under resources, there's guides on detecting with filters in R, in RInstat, as well as in Excel, OpenOffice, and Google Sheets. In Excel, because that's just what we've used here, then there's the filter menu, the filter option on the data menu, and if you click anywhere in the data, it adds these down arrows to the first row. Now, you don't need to worry too much about how this works, because we have it in the guides at the bottom, and I really recommend you go through them. If you don't have access to Excel, there's plenty of other tools out there which are easy to source and accessible, hopefully, or they should be accessible. If you do have any problems, then I'm sure that there will be a solution there for you. Our Instat, for example, is free, it's open source, but OpenOffice as well is free and open source, and these things are discussed in topic 1. Anyway, so we can then filter our data, and we get these different down arrows. So if we click on a down arrow, we can then see what values are available. So here we look at for village and we click on a down arrow, and we can see our 3 different villages. This is good. We expect to see 3 villages. This means that there were no kind of typing errors when the data was entered. And this means that our 3 villages are given. There's not any NAs in there. There's not any typos in there. So this is very reassuring to see. And because the people who had this data for the paper had most definitely, well, they said that they had already gone through and checked for completeness and plausibility, and they would have checked through for these sort of problems already. We can check on the other variables in a very similar way. So from our factor variables or categorical variables, same thing, different word for it, such as gender or marital status. If we hover, there's these comments in them, or here we go for the head of household if they're literate. If you hover over that comment, it will say what those 0s and those 1s stand for. If you then click on that arrow, it will tell you what unique values you have in there. So here where we've clicked on an arrow for marital status, it said to us our unique values are 1, 2, or 3. And this is exactly what we would expect, because those are the 3 types of variable answers that were given for that question. In each case, we can see that there's no unexpected values in the data, which is very reassuring. And then for numeric columns, the filter shows the values in this kind of ascending order. So on the right-hand side here, we're now looking for the number of individuals that attended school. This is a useful display because mistakes in the data can often lead to those more extreme values. And so by clicking here, we can see, okay, do we have any extreme values? Well, there's a minimum here of -9. This is an obvious value to investigate further. You can't have -9 members have attended school. As it turns out for this case, if you again were to hover over and look at the comment, -9 means NA. And so for a lot of software, you might actually then want to recode that -9 to say NA, because you don't want to, if you were to find the average here, you don't want it to treat -9 as an actual number, because it's not an actual number, it's not an actual value for this question. If we were to find a mean with -9 in it, it would change the story a lot more than if we were to find a mean without -9 in it. For fair reasons. And this is just a coded variable. Also with filters, we can display just a particular row of interest. So we saw here that there's these checkboxes. So we can say, just give us this -9. And if we do that, we can see that there's just one case of people for members attended school that have a -9 or have this NA. We can see that they have -9 in many other variables as well about attending school or university, which means that they didn't answer a lot of questions about this. In this case, we want to change the -9 to be NA, as we said, because it's mentioned in a comment for that variable. So we now recode all of those -9s to be NAs for this variable. We can do this just by literally changing this -9 here to saying NA. And again, the guides go through these sorts of things. So overall, both filters and pivot tables are powerful and often underused approaches to detect anomalies in the data. They can be useful to then recode these anomalies if we're certain what that correct value can be, or should be. If we're not certain what that correct value should be, and we are certain it's incorrect, well, then we can speak to some experts and decide where to go from there. Thank you very much.